Good day, class. I am Princess Sagum, and for today's lesson, I will be discussing to you about finding the determinant of matrix using the cofactor expansion method. But before we start, let us first define the concept that we will be needed, and that is the minor of an element and the cofactor of an element. So what is the minor of an element? Minor of an element is equal to the determinant of the remaining elements of the matrix after excluding the row and a column containing the particular element. So how about the cofactor of an element? The cofactor of an element, on the other hand, can be calculated from the minor of the element. Moreover, the cofactor of an element is equal to the product of the minor of an element and a negative 1 to the power of position values of row and a column of the element. To make it short, cofactor of an element is equal to negative 1 raised to I plus j times the minor of an element. So for you to understand the definition or the difference between the minor of an element and the cofactor of an element, let me give you some examples. So as you can see on the screen, we have a 3 by 3 matrix. For the minor of an element, we must cross out a row and a column, and it will be like this. So the remaining side is now what we called the minor of an element A, which is A22, A23, A32, and A33. While for the cofactor of an element A, on the other hand, as I said earlier, it is just equal to negative 1 raised to I plus j times minor of an element. Or, cofactor of an element is equal to negative 1 raised to I plus j times A22, A23, A32, and A33. So now, let us talk about the formula that we will be needed in finding the determinant using the cofactor expansion method. What you can see on the screen right now is the formula for cofactor expansion method, which is the determinant of A is equal to summation of negative 1 raised to I plus j times mij times aij. So I know that you are now having a confusion about this formula. Or maybe asking, where did I get the mij and aij here? So to explain it further, for mij, it is just the minor of an element, while for aij here is just the deleted row. Let us now go back to our previous example. For the values of aij here, as you can see, the values of aij here is the A11, A12, and A13, or just the deleted row. While on the other hand, the values of mij here is A22, A23, A32, and A33, or what we call the minor of an element. So now, I will give you another example in a 4 by 4 matrix, but this time, we will now using the cofactor expansion formula. So the direction here, of course, is to find the determinant of A using the cofactor expansion method in a 4 by 4 matrix. So there are 5 steps in solving this. First step is to write the formula, which is the determinant of A is equal to summation of negative 1 raised to I plus j times mij times aij. Second step is to identify which row would you like to delete. And in my case, I will choose to delete the first row. Third step is to identify the aij. In this case, our Aij here is the first row, where Aij here is equal to 1, -2, 0, and 3. Next step is to solve for Mij, where Aij is also equal to Mij. So in this case, A11 is equal to M11. Since we have already deleted the row 1 earlier, let us now delete the column 1. So after crossing out the row 1 and the column 1, all we have left is what we call the minor of an element, which is M11 is equal to 1, -5, -1, 0, 2, 3, 2, 1, and 3. And after finding out the minor elements, we will now do the basket weave method. I know that you already have an idea on how to use the basket weave method, so I won't teach it in detail, since it is the easiest way to find a determinant in a 3x3 matrix. So to continue, M11 is equal to 6 minus 30 plus 0 plus 4 minus 3 minus 0, which is equal to -23. So the value for M11 here is equal to -23. And to find the values for M12, M13, and M14, it is just the same method as what we do in finding the value for M11. So again, A12 is equal to M12. Since we have already deleted the row 1 earlier, let us now delete the second column. So after crossing out the row 1 and the column 2, all we have left is M12, that is equal to 2, -5, -1, 1, 2, 3, 4, 1, and 3. And after finding out the minor elements, we will now do the basket weave method. So M12 is equal to 12 minus 60 minus 1 plus 8 minus 6 plus 15. And we will now have the value for M12, which is equal to -32. So again, A13 is equal to M13. Since we have already deleted the row 1, let us now delete the third column. So after crossing out the row 1 and column 3, all we have left is M13, that is equal to 2, 1, -1, 1, 0, 3, 4, 2, and 3. And after finding out the minor elements, we will now do the basket weave method. So M13 is equal to 0 plus 12 minus 2 minus 0 minus 12 minus 3. And we will now have the value for M13, that is equal to -5. So again, A14 is equal to M14. Since we have already deleted the row 1, let us now delete the last column. So after crossing out the row 1 and the column 4, all we have left is M14, that is equal to 2, 1, -5, 1, 0, 2, 4, 2, and 1. After finding out the minor element, we will now do the basket weave method. So M14 is equal to 0 plus 8 minus 10 minus 0 minus 8 minus 1. And we will now have the value for M14, that is equal to -11. So after getting all the values that we will be needed, We will now proceed to our last step, which is to calculate the determinant for A. So again, Aij is equal to 1, negative 2, 0, and 3. While Mij is equal to negative 23, negative 32, negative 5, and negative 11. And again, for our formula, we have the determinant of A is equal to summation of negative 1 raised to I plus j times Mij times Aij. Now, let's substitute all the values from this formula, where the determinant of A is equal to negative 1 raised to 1 plus 1 times negative 23 times 1 plus negative 1 raised to 1 plus 2 times negative 32 times negative 2 plus negative 1 raised to 1 plus 3 times negative 5 times 0 plus negative 1 raised to 1 plus 4 times negative 11 and times negative 3. After calculating all the values, we can now get the value for determinant of A, which is negative 54. So that's all for today. Thank you for listening and have a nice day.